Hi, in this video we talk about the basic concepts like laminar flow, momentum, density, viscosity, and Newton and fluid, and some examples. The first concept is laminar flow. Is the one of two main types of fluid flow. Laminar flow is called laminar or current. The motion of fluid is other extreme fields of in laminar flow, the fluid moves in parallel plates and each particle without intermixing fluids flows a smooth path. Called power line, in laminar flow, the side transport mechanism is exclusively molecular. It can occur in the electric showers we see that have parallel lines. The laminar flow is typical of fluids at low speeds or high viscosities, whereas low viscosity fluids, high speed or high flow rates are usually turbulent. The Reynolds number is an important dimensional parameter in the equation describing under what conditions the flow is laminar or turbulent. In the case of fluid moving in a pipe of circular section, the flow will be laminar since below a critical Reynolds number. Reynolds numbers higher turbulent flow can be standard indefinitely wherever the Reynolds number turbulent flow and the limiting laminar depends on the geometry of the system and also the transmitting from a laminar to turbulent flow is generally sensitive to noise and imperfections in the system. The laminar velocity profile has a pipe shape of a parabola, where the maximum speed is in the tube axis and the velocity is zero at the pipe wall. In this case, the energy loss is proportional to the average speed, much lower than in the case of turbulent flow. Other concept is momentum. Classical mechanics, the linear momentum or translational momentum, Newton per second is the product of the mass and velocity of an object. For example, a heavy truck moving rapidly has large momentum. It takes a large or prolonged force to get the truck up to this speed, and it takes a large or prolonged force to bring it to a stop afterwards. If the truck were linear or moving more slowly, then it will have the less momentum.
A fluid is a substance on continuous mediums that inform continuously in before applying the stress or shear stresses regulates in magnitude therefore. It can also be defined as fluid substance that, to its law intermolecular equations, lacks its own shape and adopts the shape of its container. A non-Newtonian fluid is whose viscosity varies with shear stresses it's applied. As a result, a non-Newtonian fluid does not have a value defined on constant viscosity, unlike a Newtonian fluid. A Newtonian fluid is a fluid viscosity that fractional shear stresses are directly proportional to velocity gradient. The velocity gradient is a point proportional to shear stresses at point. For example, the Newton's laws of viscosity is that tau, or the shear stress, is equal to viscosity by the velocity gradient. That is an example of velocity profile between two plates and that's a steady state. What we saw was like honey was shifted, but in order to describe mathematically, we separate plates of honey like that. I mean, that the moment is given plate on plate, and considering the shear stress, now we obtain the velocity profile. For example, I will take a slice of toasted bread and put honey. I will increase the angle of inclination to slice of bread to see how the honey is viscous fluid moves. See that? Now, it can be seen as moved and spread over surface, but what happens if I move backwards? Which the moves in the opposite directions, well, already happens. They see it moving faster by moving about herself, and the friction coefficient decreases, and therefore the shear stress as well. Once it reaches the steady state, must apply shear force F to keep the moment on the inner set. This force is given by that expression, where the viscosity is expressed with the letter mu. The viscosity is a property of fluid that opposes the relative moment of acid layers in the fluid. Two things about the viscosity. The density gases increases with the temperature, and the fluid viscosity decreases with increasing temperature.
Differential equation. Nothing else. Thanks.
Hello guys, my name is Valeria. I'm going to explain the shear stress. I hope you can understand it and read it. Are you ready? Continuing the explanation, what introductory talk about the transfer of the moment. The transfer of the moment is characterized by studying the movement of fluids and the forces that occur, except for the forces acting distance. The forces acting on a fluid as pressure and shear come from a microscopic molecular level transfer of momentum. Okay, as explained about very important concepts, we stand a little explanation about what is the shear stress, which is already essential for the transfer of momentum. Shear stress. Shear stress is the force per unit area required to maintain a constant speed of movement of a fluid. Mathematically, the shear stress may be defined as where F and A is the area in which the cutting force acts. refers to shear stress. But now we will see applied to viscosity of a fluid, which is, as we know, can be Newtonian or non-Newtonian fluid.
In the following diagram, the movement of a fluid as well as the different parts and concepts already explained, and the equation we have u velocity, y transversal distance, a area of the contact with the fluid, tau applied to fluid shear, nu viscosity. The figure shows that UO divided by YO equals differential U divided by differential Y. The shear stress is observed in terms of viscosity.